So let's try another example here dealing with our inverse trigonometric function integrals right here. And we'll notice right here we're taking the antiderivative of x plus 3 over the square root of 9 minus x squared dx. And that does look an awful lot like our a right here, except that we've got this x plus 3. So what do we do with that? Well, this is a case where we will want to divide up this fraction into two separate fractions, and I'll do that right now. This is, in fact, the same thing as saying, let's take x times dx and divide that by the square root of 9 minus x squared, and add 3 times the integral of dx over the square root of 9 minus x squared. Now these are two really similar looking fractions right here, but we'll notice that in the case of a, that is going to be our arc sine right here. It certainly looks like that situation. It actually fits. But the first case right here, well, it doesn't quite look like that, right? Because we've got that x up there. Now we should remember at this point that it depends on how we want to set this up. This could be a direct substitution problem over here. So on the left, I'll do this in green. I'm going to separate these into two different colors. In green, I'm going to say, well, if we were to let u equal 9 minus x squared, what would that mean to us? Well, the answer is that du would equal negative 2x times dx, and we almost have that up here in the numerator, right? If we just factor out negative 1/2 from both sides, negative 1/2 of du would certainly replace x dx. And so on the left, we have the quantity negative 1/2 of u to the negative 1/2 du. All right, now I'm going to switch colors over here because I want to come over to the right-hand side, and let's treat that one. In this case, this is a denominator that certainly looks like this one over here in formula letter A right here for our arc sine, where we have the integral 3 times the antiderivative of dx divided by the square root of 3 squared minus x squared, and right away that fits our formula. So we really don't need any more adjustment right here. We're just going to take this as it is. And what's going to happen? Well, all right. On the left, when we take the antiderivative of negative 1/2 u to the negative 1/2 du, we're going to get negative 1/2 times negative 1/2 plus 1. 1 over that is 2. U to the positive 1/2. For our second part over here, of course, we're going to get 3 times the antiderivative, which is going to be arc sine of u over a. Well, in this case, that's x over a. And then, of course, our constant of integration plus c. So when we replace all of these things and rewrite our expression, that means that we're going to have the following. 2 cancels out. We're going to have negative the square root of 9 minus x squared in the first term plus 3 times the arc sine of x over 3 plus c. By the way, I guess I should put down here, we've got a is equal to 3 since a squared is equal to 9. I'm making that replacement right here. Right there. Okay, there it is. So this is our answer. This is what our antiderivative is. So with a little bit of creative rewriting, we can generally, if we see this kind of structure in the denominator, one of these structures that look like one of these things in the denominators, we can try to rewrite that expression in such a way that we can take advantage of this rule. All right, more to come.